Hello viewers. Welcome to this channel. Please like and subscribe this channel. Modern cargo ships are provided with a large low-pressure distilling plant for producing fresh water during the voyage, as the capacities required would otherwise need considerable tank space. This space is better utilized to carry oil fuel, improving the ship's range. A considerable amount of fresh water is consumed in a ship. The crew uses on average about 70 liters per person a day, and in a passenger ship, consumption can be as high as 225 liters per person a day. Water used in the machinery spaces as make-up for cooling system losses may be fresh or distilled. But distilled water is essential for steam plant where there is a water tube boiler. Steamship consumption for the propulsion plant and hotel services can be as high as 50 tons per day. It is now common practice to take on only a minimal supply of potable water in port, and to make up the rest by distillation of sea water. The saved storage capacity for water is available for cargo and increases the earning power of the ship. A vessel which carries sufficient potable water for normal requirements is required. If ocean-going, to carry distillation plant for emergency use. An advantage of low-pressure evaporators is that they enable otherwise wasted heat from diesel engine jacket cooling water to be put to good use. Warning is given in Notice M620 that evaporators must not be operated within 20 miles of a coastline and that this distance should be greater in some circumstances. The main object of distillation is to produce water essentially free of salts. Potable water should contain less than 500 mg per liter of suspended solids. Good quality boiler feed will contain less than 2.5 mg per liter. But seawater has a total dissolved solids content in the range 30,000 to 42,000 mg per liter. Depending on its origin, but the figure is usually given as 32,000 mg per liter. Low-pressure evaporators for the production of water can be adapted for steamships but operate to greatest advantage with engine cooling water on motor ships. The relatively low temperature jacket water entering at about 65 decks and leaving at about 60 decks will produce evaporation because vacuum conditions reduce the boiling temperature of sea water from 100 decks to less than 45 decks. Okay, let's get into the topic. The first component of the freshwater generator is a freshwater pump, which is used to supply the generated fresh water to ships' freshwater tanks by taking suction from the freshwater generator. The next component is ejector pump, which supplies pressurized seawater to the ejector for creating vacuum. And it also supplies cooling water to the condenser for cooling the fresh water vapors. The third component is air, brine ejector. This ejector is used to remove the accumulated brine from the fresh water generator and to create the necessary vacuum inside the fresh water generator. Next is evaporator. It is used to boil off the seawater at lower temperature, with the help of vacuum created by the ejector. Condenser is used to condense the freshwater vapors and collect them in liquid form for further use. The other components of the fresh water generator is main engine jacket water line with the bypass valve, relief valve, vacuum gauge, thermometer, vent cock and a selenometer. The vent cock must be closed before operating the fresh water generator. Let's get into the operating procedure of the fresh water generator. Open ejector pump line discharge and suction valves respectively. Open the feed water valve to fresh water generator. Start ejector pump. Water will pass through the condenser and air brine ejector and supplies feed water to the evaporator. By this the ejector will create the necessary vacuum inside the fresh water generator. Open the jacket water discharge valve and then inlet valve to the evaporator simultaneously. Shut the jacket cooling water bypass valve for fresh water generator slowly. The jacket water at 75 to 85 degrees Celsius temperature will heat up the seawater at low pressure or vacuum, so the water boils at lower than normal boiling temperature. The generated water vapor will rise and pass through the demister of knitted monal metal wire, which will remove the carried salt and only allow water vapor to pass through. The shell temperature will increase and there will be a slight drop in the vacuum. This indicates evaporation has started. The vapor which passes through demister will get cooled down by the seawater cooled condenser and will get collected as fresh water. Unevaporated water and salts are getting collected as brine at the bottom and discharged by the brine ejector to overboard. Now open the fresh water distillate pump discharge valve and bypass valve of salinometer. To initially check the salt content, keep shut the discharge valve to fresh water tank. Start the fresh water distillate pump. Check the salt content by tasting the water. Once the salt content decreases, switch on the salinometer and keep the alarm in mute. Shut the bypass valve and activate the alarm once the salinometer goes below the alarm limit. Finally, open the fresh water tank filling valve. This is the working of the marine fresh water generator. Thank you.